So we're going to move now to having a look at the probiotics, the gut flora, the good guys. And as we said before, there's a lot of them, about 10 times more bacteria live in our gut than there are cells in the human body. So gut flora composition is linked to a lot of health conditions now, lifestyles, population studies. A probiotic is a live microorganism that, when administered in adequate amounts, confers a health benefit on the host. That is official from the World Health Authority. The term probiotic is derived from pro, meaning for, and bios, of course, meaning live. The concept of probiotics evolved at the turn of the 20th century from Eli Metchnikoff, the Nobel Prize winner Russian scientist, who suggested that the long, healthy life of Bulgarian peasants resulted from their consumption of fermented milk products, in other words, yogurts, which in fact was the first sort of yogurt I can remember back in the 1950s, 60s. It was always Bulgarian yogurt, it was called, because it had Lactobacillus bulgaricus, was the one that made the yogurt in those days. That was the only one we ever got, so it's called Bulgarian yogurt. There's Metchnikoff, who first suggested the possibility of colonizing the gut with beneficial flora as early as the early part of 20th century. At that time, he was professor of the Pasteur Institute, and he proposed the hypothesis that aging process results from the activity or putrefaction of microbes producing toxic substances in the large bowel. Well, we've looked at some of those, like the ammonias and the acetones of free aldehydes. Proteolytic bacteria such as Clostridium, which are part of the normal gut flora, produce toxic substances, phenols, indoles, ammonia, from the digestion of proteins. According to Metchnikoff, these compounds were responsible for what he called intestinal auto-intoxication. I think we'd probably call that endotoxicity now, would be a better word, probably that, which would cause the physical changes associated with old age. So benefits of probiotics are numerous. Competition for the binding sites in the intestinal wall against bad bacteria. They help for essential nutrients, produce micro substances, a stimulation of mucus, stabilization of the intestinal barrier in order to prevent leaky guts, improve gut transit because they're part of the bulk of feces. They produce these volatile acids, immune modulations. They aid carbohydrates, they produce the short-chain fatty acids. Synthesis of certain vitamins, particularly vitamin Bs, which don't have a number. So when we talked about vitamins in the second seminar, second module, you remember we have vitamin B1, and if it has a number, it means you have to get it from the diet. But if it doesn't have a number, we can make it inside the body. And some of these are made by bacteria in our guts, like biotin, some folates, K2, again we talked about K2 being stretched form of K1 by a special bacteria, B. subtilis, which we look at. It improves the absorption of metals, minerals like magnesium, calcium and iron. We can see here that we get coagulation. It was a number of them come together. Biosurfactant production. In other words, they can produce certain compounds which can protect the skin. They produce hydrogen peroxide, which gets rid of certain bacteria and parasites. They can talk to each other and to the cells, signaling effects. Competitive exclusion, they can lock on and stop bad bacteria from attaching. Or they can stimulate the immune system. They can modulate the immune system. So there's lots and lots of different functions of these, not just the fact that they form the feces. They can prevent allergies and obviously prevent inflammatory bowel disease. So there's lots and lots of different functions that they have if we've got a good microbiome. Maybe involved with weight loss. This is interesting because it's a different family, and they discovered this with fecal transplants, that if they, with twins, if they put a certain bacteria into one twin, they lose weight, and different bacteria in the other one, they gain weight. And The $100 question is, which one is the one? And seems to be varying reports on these, as we'll see. So we get two groups, as we'll see, that they talk about, is the balance between the firmicutes and the bacteroides. Okay? Now, the bacteroides are considered to be the gram-negative bad guys. The firmicutes are more the good guys, the lactobacillus and so on. And you've got those as a mixture here. Now, when we do a comparison, which is what you're doing here, you can be looking at, does a person strengthen to this or weaken to one of them? But a comparison is usually you put one substance on, test the muscle, and then put the other one on. So like in reference to this, how do you like that? And then reverse them around the other way. It's usually when you've got two things on, the body can say, that one I don't like in comparison to that, and so on. So it might be worth us just doing that and seeing if you react at all to a strong muscle. So we left the part there with maybe they're involved with the imbalance with the weight loss between the balance of the firmicutes and the bacteroides. And a lot of people seem to have this comparison. And then you look for the individual probiotic or probiotics that negate it. They may also, probiotics help in the prevention of bowel cancer, which of course is very important, colon cancer. So the hierarchy of biological classifications generally is that the kingdom contains a number of phyla. So when we look at probiotics, plants, and we look at animals, we start with the species, genus, family, order, class, phylum, and then the kingdom, the domain, and life. This is the biological hierarchies. So we know that the vast majority of microbial contents of the colon consist of bacteria. They also make up 60% of the dry mass of the feces by this time. Somewhere between 300 and 1,000 different species live in the gut, with most estimates at about 500. However, it's probable that 99% of the bacteria come from about 20 to 25 or less species. This was studies done in France. So of the 500 or 1,000 different bacteria, probably 20 to 25 make up the most of these. So they're the ones of interest, and they're the ones that we put in your diagnostic test kits, and they're divided between the lactobacillus and the bifidobacterium. Though people can survive without any bacteria flora, if you have a whopping great dose of a broad-spectrum antibiotic, you may destroy everything. So you can live without them, so they're not considered to be essential nutrients from that point of view. The microbiorganisms perform a host of different functions, such as fermenting, training the immune system, preventing growth. So these things would all be reduced if you didn't have the right bacteria flora. We saw that they developed synthesize certain vitamins like biotin and vitamin K2. They produce hormones to direct the host to store fats. 99% of the bacteria in the gut, particularly down in the colon, are anaerobes, which means they don't use oxygen. So in the part before that, in the cecum, which is the end of the appendix end, and the end of the small intestine, the aerobic bacteria reach high densities. This is the French National Institute for Agricultural Research, highlighted the existence of a small number of species, 20 to 25, shared by all individuals, constituting the human intestinal microbiota. The rest depend upon your diet and where you are. So vegetarians, vegans, carnivores are all going to have different bacteria that live in there. Some species are unique to some animal groups. So in other words, a dog's bacteria would not be a good one to have a transplant from. Okay? On the other hand, camels might be a good one. And because during the Second World War, when the Germans invaded North Africa, a lot of German soldiers got dysentery. And the Arabs would follow them around. They used the Arabs as servants to the invading troops there for the Germans. And they noticed the Arabs didn't get dysentery. And so they went round and followed the Arabs and asked them, why do you guys not get dysentery and our boys get dysentery? And they said, because we eat camel dung. So they followed the camels, you see. This might have been just the Arabs telling them this, or not. We don't know. But they would get a shovel and shovel the dung. So after that, the German troops had to go around and shovel it, and apparently it stopped them from getting dysentery. So you can actually buy that product now in a capsule which is made from camel dung to help strengthen up against dysentery. So that's the first instance of fecal transplants probably that we know about. So it's highlighted that 20 to 25. So the rest depend upon your diet, also the location. So if you live in Africa, you probably would be exposed to different ones than if you lived in India and over here and so on. But the hardcore is this 20 to 25 different ones. So we've mentioned about all the different functions. We'll skip all those. So there's 4 dominant types in the human gut. There's the firmicutes, which make up the majority. So these are generally considered, as you see, to be more the good guys. The bacteroides, which are 30%, may be, let's say, the balance of the bad guys. Actinobacteria, proteobacteria are the smaller ones. Then we've got naturally occurring fungi in there. Certain number of protozoa and helminths often live down there as well. Archaea, which are involved in the removal of end products of bacterial fermentation. So these 2 are the big ones. So let's work through this. So bacteria are classified usually if they're aerobic or anaerobic. So we'd be doing this in the infectious diseases. Aerobic bacteria need oxygen. Anaerobes exist without oxygen. The classification is further subdivided into 2 types, depending upon their cell wall. You've got gram-positives and gram-negatives. So gram-positive cell walls contain 90% peptinoglycan, which is made of acetylglucosamine and acetylmuraminic acid. They are stained blue, violet by a crystal violet stain. So gram-positives have acetylglucosamine and acetylmuraminic in their cell wall. Basically, they have one single cell wall. Gram-negative have 2 layers. They have a thinner inner membrane, which is composed of peptinoglycan. In other words, it's the same as this one, but the outer layer is a lipopolysaccharide, which contains the toxic lipo-A, which is responsible for the pathogenic effects. So lipopolysaccharide, which contains lipid A, is the toxic one, and that's the thing that makes you feel ill in the gut when you get a bacterial infection, which is a gram-negative. So here's the gram-negative lipopolysaccharide endotoxin. So we've got this polysaccharide chain here, oligosaccharide subunit, and then we've got this core bit within the end here is the lipid A, and this is the thing which is the real poisonous substance. So back to the firmicutes, gram-positive. So these would be more of our good guys, if you like, and generally gram-positives, let's say, doesn't mean there aren't bad ones, but generally though. So you've got Clostridia, which is botulism, which can be bad, but of course most bad ones have come from good ones originally. Lactobacillus subtilis acidophilus, these are all good ones for us. So the division of firmicutes as part of the gut flora has been shown to be involved in energy absorption and in some people managing obesity. Gut flora has been shown to diffuse between lean and obese people. There's an indication that gut flora in obese and lean individuals can affect the metabolic potential. This is apparent alteration in the metabolic potential is believed to confer a greater capacity to harvest energy, contributing to the obesity. Basically, you've got to do what we did, is you do one, the other. Sometimes people will weaken to one, which means they've got an over amount of that. But sometimes it's a ratio, you test one and then test the other and then round the other way. And it's usually that which weakens people. Just, it's a balance. In other words, they haven't got the right balance between the two. So multi-strain probiotic milkshakes may protect against weight gain because of these good bacteria. We talked about Subtilis. We'll come back to that because that's the one that stretches K1 into K2. Listeria, Lactobacillus, Helicobacteria. So you see that there's good and bad in both groups. Research suggests that the relationship between gut flora and humans is not merely commensal, in other words, non-harmful existence, but rather mutualistic in its relationship. Now, the other one, next one is Bacteroides, which generally are gram-negative. So these are the families there. It's the genus gram-negative. They can use simple water sugars when available. Their main source of energy in the gut is complex from glycans. Studies indicate long-term diet is strongly associated with the gut flora. So most of these are Prevotellers will dominate. So Bacteroides, these are all the Prevotellers and Bacteroides, these different forms here. Most of this you've never heard of. They may be beneficial to their host, but excluding potential pathogens from there. Actinobacteria, again, this is where Bifidobacterium bifidus comes in as a gram-positive. That's a good guy. Proteobacteria, gram-negative, again, generally salmonellas, etc., which are bad ones. Microbiota linked to male reproductive disorders. So those that are dominated in the seminal fluid, including Proteobacteria, Actinobacteria, could utilize fructose, which is a lot in seminal fluid, as their source of energy. So probiotics, modern lifestyle, we said all this. Taking antibiotics is not without a risk. Killing pathogens in the colon can be a hazardous venture. Antibiotics that annihilate our colon-friendly bacteria can get us into big trouble. Low levels of friendly bacteria will inhibit the conversion of lignanes to enterodilactin, which has been shown to inhibit mammary carcinogenesis. So this is maybe the relationship between the large intestine and the breast. So in applied kinesiology, the old way of dealing with breast problems and breast cysts was to rub the neurolymphatics of the tensor fascial aorta down the side of the large intestine. And maybe this is the link there of why that might. It's a liver problem, so we'd rub the neurolymphatics of the liver for breast cysts and things, but this may be a part of it as well when it comes up as the large intestine. Probiotics can change infant gut bacteria to tolerate cow's milk. So when people got lactose intolerance, which is the usual thing with young children if they're intolerant, it may be because they haven't got the right lactobacillus, which help to break lactose down into sugars. Improve the biome and increase resistance to neurodegenerative diseases, so says David Palmotto, that we've looked at before. So in other words, the more we improve our gut flora, the better we are to protecting against neurodegenerative diseases. So microbiome disturbances are due to the food we eat. We said that gut organs contain 100 times the genetic material of our bodies in a DNA store. It influences the brain. Antibiotics and over-hygiene affects the biome and increases the risk to Alzheimer's disease, according to David Perlmutter. People with the greatest diversity of the biome have the lowest incidence of Alzheimer's. So in other words, the more bugs and things you can eat, the more you can grovel around in the soil, microbes, and put them in your mouth, the better, as long as they're not the toxic ones. Diversity increases gut integrity. Gram-negative bacteria like Clostridium or C. difficile, Clostridium difficile, increase lipopolysaccharides, which create inflammation and permeability, especially in autism, Parkinson's, and Alzheimer's. So this begins to build up the gut-brain connection, that there is this interconnection here between problems with the gut, the wrong flora, the build-up of toxic substances like the lipid A from lipopolysaccharides. Propionic acid, of course, David Perlmutter didn't like at all, is a metabolic poison, which we've seen before. It increases the omega-6 to 3 ratios. It alters neurotransmitters, influence glutamate influx into the mitochondria. Here we've got from the textbook of natural medicine levels of odd-numbered fatty acids. I took this out because this verifies, really about B12. Alternatively, it's possible that the bacteria in the human gut could produce sufficient amounts of propionic, that's carbon-3, to lead to an elevation in the odd carbon fatty acids. This would only occur under conditions of significant gut dysbiosis. There was imbalance in the good bacteria. The association between B12 and abnormal fat synthesis provides a rationale for the neuropathy of cobalamin, that's B12 deficiency. Odd-chain fatty acids build up in the membrane lipids of the nervous system, resulting in altered myelin integrity and demyelination, leading to impaired nervous system function. So this is why a lot of people with MS will respond to B12 injections. So it doesn't cure it, it's not the cause of the problem, But if they are deficient in B12, they then can't burn the propionic, which could be made by gram-negative bacteria in the gut. So if they're deficient in the B12, they then start incorporating propionic acid, which is carbon-3, into the myelin, and then the myelin starts dropping apart. So always with MS, look for B12, but the toxic substance usually that will show up is propionic acid, and that has to be got rid of by adenosylcobalamin. So we looked again at this zinc deficiency, creating a low level of the digestive enzymes, in this case lipase, which leads to not being able to digest and break down fats in the colon, and this leads to the conversion of these undigested fatty acids to odd-numbered by the bad gram-negative bacteria. So again, as the kit. So here's the list of the common probiotics, and you'll see basically the ones on the left here are all lactobacillus, so they're principally in the small intestine, and the ones from 20 onwards here are mainly in the large intestine, and they're anaerobes. And then I've added 3 here, which some companies put in, but these are not ones from humans. In other words, the human is not the host, it's not the definitive host. So if you take these, you tend to take them and they can have very good effects, but at the same time you poo them out. Okay, so they don't live naturally in the human colon. All these other ones live naturally in the human beings. So we look at acidophilus, this is the common one there, creates good bacteria, curbs Candida, produces amylase, the digestive enzyme for starches, helps produce lactase to digest milk, and produces K2 for blood clotting. So small intestine produces beneficial substances against microbes, helps maintain cholesterol levels. So all 23 that we put in here have their benefits. But the bottom line is you need to test which one or ones it is. Relatively rarely is it one, because usually whatever has destroyed the microbiome has destroyed a range of them. So this is why it's important to test the individual ones and to mix and match the ones that the person shows positive to. Sometimes it's all of them or a lot of them, in which case a multiple is good, that's excellent. But what you don't want to do is to take a probiotic when you don't need it, because that can lead to an overgrowth of the one that you don't need, which they live as a family, because if you get too much of one, you get a relative decrease of the other ones. So people say, oh, I take probiotics, you've had that, I'm sure. I say, well, which ones do you take? Oh, acidophilus, and it's got something else in it. And you find the person's taking the wrong one, and they're just increasing their problem because they're increasing the ones that they don't need. Okay, so it's better to, from our point of view, always to test. So each one of these, I'm not going to stop on any of them because you can read these. There's a whole screen on each one. If you want the details, it's on our website. So there's a book on there, or 100 pages of it, are all about each probiotic. So these are just extracts taken from that. Here we've got some of them, like fermentum here is associated with dental caries. So this is one that you might find is more in the mouth. This one, Gazary, is more in the vagina. So it produces various substances which are antibacterial for the vagina. Helveticus is to convert cheese, especially in Helvetica or Switzerland. Okay, a lot of the Swiss cheeses are made. You'll see that a lot of cheeses are made in the same way. Most of the probiotics, in fact, which are developed industrially, are for making cheese and yogurts. Okay? There's huge places which make probiotics, but not for humans. They make them to make cheeses. Lactis is the one that goes on to make a lot of soft cheeses, a lot of brie and things. Lactobacillus lactis is what brie is made from. Camembert. It can make B12, interestingly, in ruminants. Paracaceae, Plantarum, Ruteri, Rhamnosus, Salivarius. This is an interesting one. Suppression of pathogenic bacteria is found to have wide coverage against pathogenic organisms. Research has shown that addition of the species along with other probiotic species may be anti-inflammatory. Interestingly, we sell more of this to the States than anywhere else. And the reason is obviously they have got something like a preserver or an antibiotic that destroys this within their normal diet. And so there's a large section of the population in America who are deficient in this essential probiotic in the gut. What it is, I have no idea, but when you've done a few visits to the States, you soon realize that there's so many preservers in all the food and so many chemicals, it could be anything really. So they all have their little good place where they live. They hang out in the intestine, if you like. So basically the lactobacillus hang out in the small intestine, and that some of them live there as residents, and they protect the microvilli around the intestine. So instead of being just one cell thick, they become 2 cells thick then, because you've got the probiotic around there, and it helps protect the microvilli from absorbing toxins. So it prevents leaky guts and things like that. And other ones form the bulk of the feces that we then pass out. So this is the bifidobacteria then. Bifidobacteria, bifidum is the most common one of them. Brevis. Infantis is the main one for infants. So this would be the one you consider for young children. So you don't want to give young children acidophilus or anything else, it'll give them tummy ache, because it's not the bacteria that they're used to. The bacteria that you look for with infants is infantis, hence its name. Bifidobacteria lactis, longum. Subtilis, this is the one which I think we are unique in our company as far as subtilis, because it's one which is being used a lot now as an alternative to antibiotics in animal feeds, where the chickens and things used to be fed antibiotics all the time. They're now feeding them with B. subtilis to build their immune system up so they don't get fowl pest and things. But the main function of B. subtilis is to stretch K1 into K2 in the gut. So it increases the immune system response in humans as well as chickens. It's used to produce various enzymes such as amylase and protease, but it comes mainly from natto, which is fermented soya, or from chickpeas, fermented chickpeas. They recognise for the contribution to a healthy gut flora and vitamin K2. So basically it stretches in some way K1 into K2, which of course has a totally different function from K1, which is the blood clotting mechanism, although the two are supposed to be interconvertible. But K2 is the one that mainly drives calcium from the tissues back into the bone where it belongs. So it does this by a carboxylase enzyme, and the carboxylase enzyme basically adds carbon dioxide to glutamate protein here. So it puts a hydroxyl, which has got a carboxyl group there, and the CO2 adds another carboxyl group, so you get a gamma carboxyl glutamic acid, which is like two magnets, like a horseshoe magnet, which grabs the calcium because it's got 2 pluses and now we've got 2 negatives, and osteocalcin here, the protein, takes it back into the bone. And osteocalcin is the main protein in the bone after collagen. It's very clever, but it's mainly it's present in fermented vegetables. So things like sauerkraut are naturally a very good source of it. Any fermented vegetable will, as long as it's not in vinegar, it has to be in brine. So if you buy sauerkraut and things, you must buy it in brine, not in vinegar. Okay, because vinegar will kill off the good bacteria. But we don't do so many food preservers in that way, fermented vegetables these days. So function, we know K2 regulates calcium, moves calcium back into bones. So this is important when you're furring up in your arteries. So if you show that you need K2, you respond to K2, we implore you to take it, because it does potentially mean you could be furring up, or you could be losing calcium, and you're not putting calcium back into your bones and your teeth. So that way it helps to fight furring up of the arteries like coronary heart disease and osteoporosis. So sources, other sources, down here it's got modern diet compromises the K2 in food, grass-fed cows, free-range eggs, cheeses like Gouda and Brie, egg yolks, butter, goose and chicken livers are good sources of K2. Whole milk from grass-fed cows, that doesn't occur very often, does it? There's certain countries in Europe are very interesting with driving through, and they're great dairy countries, and you don't see a single cow. They're all indoors, even in the summertime. Terrible. They don't eat grass at all, they all eat maize. Shan't mention which countries, but they are bad as far as I'm concerned. So whole milk from grass-fed cows, cheese made from milk containing a lot of bacterial fermentation, good eggs, more than double the K2 of battery eggs, as long as they're fed outdoors. Here's K2, that's K1, and you'll see basically it's just a stretch version with some double bonds in there, is menaquinone K type 4 and menaquinone type 7, which is a longer version. 7 is better, that's the one for fermented chickpeas and things, because it lasts longer. It'll last at least 24 hours in the system, whereas MK4, which is usually extracted from emu oil, I think that's the one from cheeses as well, isn't it? MK4, I think it's certainly emu oil and other things, but this one, MK7, is more from fermented soya and chickpeas, and that lasts, well, this one I think only lasts 4 or 5 hours, so it has a short half-life or life expectancy on it. Although a short half-life stays in the circulation for only a few hours before blood. That's the MK4 from dietary animal sources, usually emus, whereas natto from boiled soya beans, additions specialised in with the microbe bacillus, structural carbon bonds, can be sourced from, we prefer it from chickpeas personally, because so many people are allergic to soy. Soya really does have a big sort of allergic problem, and of course worldwide something like 99% of soya is now GM. So it has a longer half-life, so a single dose is sufficient. So when you had your dose of K2 once a day somewhere, it usually will last you 24 hours. Coagulans, again, used to be called spirogenes. This is not a natural one to the human gut. So this is something which is not a normal inhabitant. It's great, it's very stable for holiday trips and things. You can take this away, it's very good. It doesn't deteriorate in heat, doesn't matter about the heat and everything else. But it's not a natural one, so you take it in and then you'll basically poo it out, defecate it out, and then you have to keep replacing it if you want. But it's popular for holidays. Saccharomyces boulardii, this is actually a type of yeast. It's not a baking yeast, but it is a type of yeast from the soil, and it helps protect against C. difficile, Helicobacter, and obviously Candida and other fungal overgrowths. It's anti-inflammatory, it works to combat lipopolysaccharides. It's quite surprising how many times this one actually shows up. So childhood microbiome shows distinct and functional differences from the adult. So perhaps, as you'd expect, not just location but age as well has a big part. So what a child requires, an infant requires, is different nutritionally, and that's what we'll be looking in the next module. In this case it'll be tomorrow, is what your nutritional requirements are at different ages as you go through life. So predominant probiotics in infancy, Lactobacillus brevis, Bifidobacterium brevis, so all the small ones, Bifidobacterium infantis, which I talked about, and Bifidobacteria longus. So he's enough to make you think about having another baby, isn't he? Sweetie there. So predominant probiotics in immunity, so things that help build up our immune system. Doesn't necessarily mean you need all of these, but if you had a particular function reason for this, then these would be the ones you choose. There's plenty of scientific data on why they work. So rhamnosus paracasei, and B bifidum, B infantis, longum, lactis, S billardiae, and B subtilis help the immune system. And plantarum and paracasei, again, this one is suggesting, to help beat the common cold. So again, the theory of if you want to get rid of bad bacteria and viruses, increase the good ones. So flood the body with good ones. Predominant, again, with immunity, same ones basically. Here, this one is increased, included Bulgaricus and Casei. Probiotics prove better than placebo at reducing cold symptoms. Predominant probiotics in strengthening the intestinal bacteria. So these would be ones which will help the healing and particularly the repair, regeneration of the gut, having removed all the problems. So bifidobacteria, lactis, acidophilus, etc. So these would be your leaky gut. Good ones. Probiotics for treating depression. Bifidum, B. lactis, acidophilus brevis. So these have all got good scientific research behind each condition. So here again, the link between bad bacteria, the byproducts of this, the lipopolysaccharides, etc., creating low levels of dopamine and serotonin. So the depression, the new role for probiotics in nutritional psychiatry. We were talking about this, I think, on the way down yesterday, that in the mid-1800s, psychiatric conditions were usually institutionalized, what they called madhouses in those days, and they were just institutionalized. And then in the latter part of the 1800s, they realized there was a biochemical connection in some way. These people had abnormal biochemistry. They couldn't pinpoint what it was, but they had abnormal biochemistry. And then in the early part of the 1900s, psychoanalysts came in. So it all moved to looking after psychiatric patients by analysis. And so you had your Freud and all those people came in. So psychiatric disorders were psychiatric. They had to be regressed and go through all the analysis and things. Then that changed with the different ones that came in, like Jung and so on. And so by the late 50s, there was research being done on animals that found that animals responded and they went to sleep if they were given certain substances, certain chemicals, and other ones would perk up and were very happy by giving other things. And that was the birth of the psychotropic paranoia medications and things, which were all done on animals by chance. They thought, well, if this makes an animal go to sleep, let's take a person suffering from anxiety and do a trial on it. And so your tranquilizers came in. That was the days of the diazepams and things. And gradually, during the latter part, at this time, apparently in the 1960s, 70s, all the deans of the medical faculties in psychiatry were psychoanalysts. Okay, so they were the senior group who knew how to analyze patients. By the end of the 1900s, they were all pharmacists. So psychiatry had all become pharmaceutical. And now it's beginning to slightly go the other end because there's no evidence that we're any closer to treating psychiatric problems. They're being controlled, but you take the medication away and they're just the same. Whereas they were getting the same results in the 1940s and 50s by people giving people exercise to do and treating their thyroids. They found an enormous number of psychiatric problems were due to low functioning thyroids. And exercise and hot baths and thyroid medication work just as well as anything else. So it's interesting now that they're beginning to come around to maybe it's biochemical again, not a deficiency of a drug to manage it, but maybe it's biochemistry, the wrong chemistry, and some of that chemistry could be coming from the gut with people. You know, I found this years ago. This was my first real evidence of this with a lady who suffered from bipolar disease, and she was really, when she was down, she was really down, almost suicidal, and when she went up, she was high as a kite. But you'd only go up for a day or so and then down for 2 or 3 weeks. And we found, we went through all the foods with her, and it was bananas. And when we took her off bananas, the bipolar disappeared. Now, since that time, we've learnt that in bananas, particularly bananas that are going off a bit, there's a substance called tyramine, And tyramine has a drastic effect on dopamine and serotonin levels. So what was happening is she was going down, the dopamine was crashing. And she had a banana every day. And so when she peeled the banana, and the banana, if it was fresh, it was okay. So she was all right on that time. But as soon as she had one which was old, which got the black spots and things or brown spots on it, it was beginning to go off. The tyrosine was beginning to oxidize to tyramine, and that was just playing havoc in the brain. So a lot of psychiatric problems are probably due to the food that people eat. For some reason, they're unique in the food reactions that they get, that other people can eat it and have no problem. So what we eat is very important as far as what we become, but we're now learning, or they are learning in psychiatry, that psychiatric problems are probably biochemical, but maybe due to toxins rather than other factors, and certainly not necessarily from emotional problems. They can end up with counselling for years and years and years and really not get very far. They might have found out all the problems that they've had with their mother, but they still can't actually get rid of the fundamental beneath them. So gut bacteria could counteract depressive tendencies. So one of the most important places to look for all chronic disease is back to the gut, particularly if that's the meridian that shows the entrance into their problem. So predominant probiotics in brain-gut axis, rhamnosus, bifidum, longum. In oral health, we talked briefly about oral health here. You had a look at your partner. Here we got receding gum. You see it's receding there. We've got periodontal. You're beginning to see a bit of the root of the tooth here, and the gum round here is red, which means basically it's inflamed. Very easy. You just touch it. Anybody who shows a folate deficiency, any type of folate, lift the gum up, lift the lip up, and you see the receding gum. TL any of the receding gums there, and you'll find it's negated with the folate usually. Possibly B6, as we said, but certainly this is real bad folate, and of course bacteria forming the plaque around the teeth. See the plaque there, emphasize all that horrible yellow stuff. So these are the bacteria that are required to improve the oral health. Switching a family diet determines infant gut bacteria. So very much the findings go against current thinking that suggests the effect maternal obesity has on children's gut bacteria may occur through the dietary habits of the family. Recent studies have also suggested the heredity of obesity may partly be caused by the transmission of gut microbes that promote weight gain, which we've looked at there. Big gut data tracks impact of hygiene, restoring the damaged baby microbiome is the biggest development in infant nutrition in years. So predominant probiotics in the vagina, so this would be for vaginal thrush and vaginitis conditions, would be this one. Women misinformed about discharge may douche to clean the vagina, but this upsets the bacteria and fungi balance and can lead to more chronic fungus, thrush and bacteria vaginosis. Probiotics may prevent recurrent vaginal infections. Probiotics are back for vaginal health. Gut bacteria linked to risk of heart attacks. As we said, even dentists are talking to cardiologists, and they know the state of the teeth and the bacteria in the teeth can influence the heart. We've looked at the therapy localization points on the splenic fracture and the hepatic fracture, but this other point, remember, of the root of the mesentery. So the umbilicus, pubic symphysis, halfway there, which is the triple warmer alarm point, and halfway between that and the umbilicus is conception vessel 6. So you therapy localize there, no problem, okay? Press, therapy localize, and they go weak. And this is an indication the need for probiotics. So could we have Maria back up again just to demonstrate there. So what we do is we take a strong indicator muscle. So let's pop you up on the table. So we bend up here and pull the knee to the shoulder. Just keep it up, that's it. So we take the position halfway, so pubic symphysis here, halfway would be triple warmer, halfway between that is conception vessel 6, which would be there. So put all the hands, all the fingers on there, and that's it. And don't press, just touch. So pull, no problem. Now press as firmly as you can in there, and she goes weak. Okay. So here we got a need for probiotic. It might be one probiotic, it might be more than one, in which case you build up a little personal profile of which ones it is. So you would need to be pressing fairly firmly in there, and then we test through the 20 or so in the test kits. Okay, thank you. So tailor making it depends upon the diet. You know, we don't know what food preservers, what sort of benzoates, benzoic acid, the things they use as food preservers, which specific bacteria they destroy. But generally you can say, well, you look at food preservers, this is the major thing. You look at chlorinated water, so you get them to get a water filter, a jug filter, use bottled water as an alternative. Don't touch antibiotics. We know that antibiotics are fed enormously to chickens and possibly to other animals. Always use organic meat where possible, but certainly chickens are fed it. Chicken, the antibiotic destroys and inhibits the complexes in the mitochondria. So as a result, the chicken gets chronic fatigue syndrome and gains weight. So the fastest way to fatten up a chicken is to give it antibiotics, they found, which they were using for controlling fowl pest, apparently, which is a bacteria or virus which goes throughout the deep litter houses in intensive farming. But they found it's interesting that the chickens put on weight as a result of it. You know, just like some humans, if you change the microbiome, put on a lot of weight, and the chicken did as well. And this was the fast ways of fattening chickens up. You can make a lot more money that way if you can fatten a chicken up in so many weeks as opposed to so many months. So where possible, I wouldn't touch factory farm chicken. So probiotics there. So the probiotic approach, the human microbiota contains, oh, we said all that. Right. So the last topic really that we want to have a look at today is a little bit more in detail about the digestive enzymes. We talked about the stomach pepsin here. In a way, bile is like a digestive enzyme. We put it in the dissection of that when we do a check of the gut. But the main ones otherwise, apart from that, are the pancreatic stroke small intestine ones which come together. So we put these in this section in the kit. Now, this is a very, very important statement, as we'll see, because you are not what you eat. Well, you are, but you are not what you eat, but what you absorb. And this is the critical thing that we're finding more and more, because this is something we'd never really looked at. We've assumed that when you eat food, or if you need to take a food supplement of some form, that what goes down the mouth gets into the body. But more and more research indicates that it's nowhere near as much as what we think. Every textbook will tell you that only 30% of magnesium within our food is absorbed. That means you have to take at least 3 times the amount of food with magnesium to get what is required to get you recommended daily allowance, which could be 300 to 400 milligrams per day. Our observations, and again research, is that vitamin C is only 15 to 20%. 15 to 20% of vitamin C, if you take it as a tablet or capsule of ascorbic acid, is actually absorbed. So when you've got a cold or something like that and you think, oh, you need vitamin C, and you need vitamin C, you don't take a gram. You need a hefty dose of vitamin C. 10, 15 grams is a more acceptable sort of effect to get the effect of 1 gram. Okay? So vitamin C is something which you need high doses if you're going to use it as a stimulant to the immune system. You can eat the best of foods and then take the best well-balanced supplements, but if you don't digest these and absorb these, then malnutrition will incur and less optimal health. So this makes sense with what we saw this morning, not digestive enzymes, but the whole of the absorption. And all those phospholipids, the cell membranes, are made of oils. And now we've seen time and time again that the majority of people, we all eat oils. We have to eat oils in our diet, of course. The majority of those oils are bad. So it's not surprising we cake up, really, inside our intestines. We gradually get more like, I always tell patients, that more like ping pong balls than bubbles in the bath. So, things will go into a bubble in the bath, but they won't go through a ping pong ball. And so you absorb gradually as we get older and older, less and less. And they know that on animal experiments, where animals live in zoos, they live their life expectancy. If they live in the wild, they get eaten by predators at some stage when they're the weaker out in the jungle and things. But in zoos, they had no idea how long certain animals live. And they will live a long time, and there's only one thing that kills them off at the end, and that's malnutrition. They die from malnutrition because ultimately they don't absorb what they eat. Okay, we gradually cake up, in other words, and get less and less function. We were in Cairns in Australia, up in the north there, 10, 15 years ago, and there was a park there which had a crocodile there, chained up, which is rather cruel. This thing must have been at least 20, 25 foot long. This is a crocodile, not an alligator, this is a crocodile. He was captured because he ate a policeman on the beach. The policeman must have been walking along the beach or went there, and this thing snapped at him and ate him. And then with that, they captured him. The difference was this policeman was walking on the beach in 1860. He was still chained up. So these crocodiles live to phenomenal ages. It's like lobsters. Lobsters can live, they reckon, 900 years or something, don't they, if they don't get caught. And so phenomenal. Reptiles have very, very long life expectancies, as long as a predator doesn't catch them, like a human being. But he caught the copper rather than the other way around. So you are what you absorb. So if you are full of bad oils, you're going to absorb less. So the first thing we think about someone who's got a malabsorption problem is the right oils. Look at their diet. What oils do you use? Get them onto the right ones, and maybe supplement them with phosphatidylcholine. But our preference is probably lecithin. But if you do use a soya one, which we don't really recommend, but if you do, muscle test them for tolerance for all these sort of things, because so many people are allergic to soy, and particularly if it's not organic, it'll be GM. So the function of the gut is to break down big molecules, we said, into small ones. The gut is not a major avenue for eliminating waste from the body, but only small amounts of excretory products are normally eliminated in the feces, which should be made up, as we said, about a quarter water, quarter mucus, quarter insoluble fibre, and a quarter bacteria. Therefore, if a person's not functioning properly, like they got constipation, you need to have a look at these things. Are they drinking enough water? This is a big issue, isn't it? The first thing, someone's constipated, do they drink enough water? Do they have enough insoluble fibre? So do they have enough bran and things in their diet? Do they have enough good bacteria? And mucus would be down on the last part. The majority route of elimination of toxic matter is actually through the skin, the urine mainly, water-soluble toxins, skin and lungs. The digestive action is controlled by the secretory enzymes. The gut is the home of billions of bacteria, which we've seen. The absorption depends upon the integrity of the gut membranes. The lining is deeply folded and covered with many microvilli. Some people may experience selective malabsorption, show a specific nutrient deficiency. The colon contains symbiotic bacteria that produce vitamin Bs and short-chain fatty acids. We've talked about the 10 times more bacteria in there. Toxic colon disorders are associated with higher levels of various anaerobic bacteria such as Clostridium difficile. The integrity of the colon bacteria is controlled by the acidity of the mucus as well as by fibre. Remember, the thing that controls mucus is carbonic anhydrase, which is a zinc-dependent enzyme. So carbonic anhydrase is obviously a an enzyme which is in the test kits. Undigested food in the stools leads to rapid bacterial multiplication and the production of toxic metabolites, some of which may be carcinogenic, but certainly create fermentation and gas. We talked about undigested proteins, sugars, fats, creating fungal and parasitic overgrowths. Leaky gut syndrome. So potentially a person's got a leaky gut. The best marker for this, without doing the mannitol lactulose test, which is the standard sort of lab one, is to test with lipopolysaccharide and propionic acid. So anybody who has high level of propionic acid or weakens to lipopolysaccharide as a marker potentially has got a leaky gut. That means that the barrier between the cells is breaking down, so they're not tight anymore. The tight barrier between the cells is parting, and that means that things can get through between the cells straight into the blood. Postprandial toxicity. This means after eating, test with amino acid derivatives. We're going to look at some of those. And metabolic endotoxicity, we test with chemicals that are produced in the gut, like propionic acid and indoles. So metabolic toxicity basically means things that we produce inside the body. Endotoxicity, in other words, we can produce toxins inside the body which we need to eliminate. And a lot of these occur in the bowel. So the digestive enzymes are proteins, remember, and protease, amylase, lipase. Secretion begins in the mind. So you think about food first of all, and then you start secreting. So you need to concentrate on how nice the meal is and things, rather than reading the paper or on your phone. So really, when we go to the restaurant here in the morning, the majority of people are on their phone in the morning or looking at a computer, a screen, small screen, at breakfast time. Well, that's not really doing anything. They're not really enjoying their breakfast. They're just filling it out. So if they're not thinking about their food, they're probably not producing stomach acid, and maybe they're stressed. And stress is a sympathetic activity, and sympathetic shuts your gut down. Okay, parasympathetic, what gets your vagus nerve going, and most of the gut is controlled, gastrointestinal system is controlled by the vagus nerve. So you need to be relaxed, and the happier you are, more joyous at the meal time, the more you enjoy the food and things, the better your digestion. Obviously, if you're stressed, you're sympathetic rather than parasympathetic. Good thoughts lead to optimal enzyme secretion. Anxious, stressed thoughts lead to low enzyme production. Digestion begins in the mouth with alpha amylase and starts to help the digestion of starches. Gastric digestion then with the aid of secretin, gastrin rather, a hormone produced by the stomach initiated by protein intake. Gastrin stimulates the parietal cells to secrete hydrochloric acid. That's from the parietal cells there, what we looked at earlier. HCl makes the ingested food more acid, sterilizes the stomach. We talked about the conversion of pepsinogen, conversion of proenzymes to an active form, require the cofactor zinc. Maybe in a few people, selenium and manganese show, but maybe this is to detoxify heavy metals. Selenium recycles glutathione, which is the main metal detoxifier. So it's possible that one of the reasons why you don't produce so much hydrochloric acid could be that you've got too many toxic metals. And the main one of that would be mercury leaking from amalgams. So when you leak mercury, you swallow that mercury, it goes down into the stomach, and mercury displaces zinc. So if you've got low zinc in the stomach, means you can't make carbonic anhydrase, so you get what I call a dry stomach, in other words, one which doesn't have as much hydrochloric acid as it should do. Pepsin, we said, is one of the principal protein degrading enzymes. It partially digests, the partially digested food after the period of stomach time pumps into the small intestine, and it's less acidic then in the small intestine. It's still acid, but it's less acidic. So these enzymes are secreted by the pancreas. They're then released into the duodenum, and then stimulated by secretin and cholecystokinin, the two small intestinal hormones that stimulate the acidity. Pancreatic enzymes are then secreted in a sodium bicarb matrix, so this decreases the acidity down to a pH of about 6. So in the small intestine, it's not alkaline, but it's much, much less acid. So both the production of hydrochloric acid and bicarb require the enzyme carbonic anhydrase, the zinc-dependent enzyme. Insufficient carbonic anhydrase leads to underacid in the stomach and less alkaline in the small intestine. Deficiency of the pancreatic enzymes leads to gas formation as a result of undigested and unabsorbed nutrients travelling to the colon. The most common gases we've learnt now are methane, carbon dioxide, hydrogen and hydrogen sulfide. Pancreatic secretions adapt to the diet, thus high protein diets induce protease enzymes. So if you go on a high protein diet, you should, in a good functioning body, just produce more digestive enzymes for proteins. This is why a person who changes his diet may experience digestive symptoms if they do it too quickly. So high starch diets induce high amylase, but it doesn't always come immediately. So if you change diet suddenly to a high protein diet or to a high carbohydrate diet and you don't produce your amylase or your protease, then you may get indigestion. So the best thing is to change your diet slowly if you want to go more into one direction rather. So here we got fibre is another one. When I first qualified and went to work in the health hydro, the main thing with this health hydro is you had a big, huge salad every day at lunchtime. I wasn't used to that. As a student, you have Fray Bentos meat pies and things and sandwiches. But to have a lovely salad there, and we would have muesli with organic, they made their own yogurts and things now. So you would have a very high fibre diet with the muesli and all this salad. And everybody found the same when you started work there. You just couldn't eat it all. But after a few weeks, you weren't getting bloated anymore. You were better. You'd adapted to the diet, which obviously we have to do. So there's some natural enzyme inhibitors. Soya beans inhibit protease. That's interesting, isn't it? Because soya beans are a big part of protein sources these days, and yet they inhibit protein enzymes. Beans and peas generally inhibit amylase. That's why, again, you get bloating after eating beans. There's the old thing about baked beans and things, of why you don't digest your starches and you get wind. So pancreatic enzyme secretion is greatest about 1 to 2 hours after eating. Fluids taken with meals stimulate the gastric secretion for optimal acidity and promote enzyme and bicarbonate secretion in the small intestine. Liquids preferably should be at a room temperature and 1 to 2 glasses for optimal intestinal function. Acidity of certain foods such as citrus slows down the emptying of the stomach and elongates the digestive phase. So citrus. Thus taking vitamin C as ascorbic acid may slow the digestive process and prolong the release of nutrients into the bloodstream. Vitamin C as ascorbates do not produce this effect as they are less acidic. So here you would need actual ascorbic acid rather than magnesium or potassium ascorbates. A 90% loss of the enzyme secreting pancreatic cells must occur before actual clinical symptoms of malabsorption appear, but there is evidence that chronic pancreatic enzyme insufficiency may contribute to a variety of adverse health effects well before this indication of pancreatic disease. So we're fortunate because we would pick this up on our muscle tests. So remember the latissimus dorsi, middle trap, lower trap, and the triceps would start to show this up. Potentially that we haven't got a pathological change, but we may be getting a physiological change. When food enters the stomach, the acidity of the gastric environment may be quite high, sometimes so high that many enzymes present in the food are denatured and become ineffective. This is one of the reasons that many vegetable enzymes such as papain and bromelain have been found not to be as useful in promoting digestion of food as animal-derived enzymes. Pancreatic enzyme replacement is usually by bovine or porcine extracts and administered orally have been shown to withstand even high stomach acidity. But remember, don't give pepsin in it if it's a pancreatic enzyme that you want to get to, and preferably use a delayed release. In other words, a particular type of capsule which only breaks in a pH of 6 and not one that breaks in a pH of 1. Otherwise it will burst in the stomach and you won't get the benefit of the pancreatic enzyme. Bile, lecithin, cholesterol, bile salts is important in the emulsification of fats. Deficiency leads to a deficiency of essential fatty acids along with a deficiency of fat-soluble vitamins, A, D, E and K. Effective biosynthesis, as we saw, requires taurine, glycine, vitamin C, magnesium and copper. Here we see amylase is a calcium dependent. You see here's the zinc, which we talked about before, and this is calcium. You see the cofactors locking on to the enzyme and activating it. I pop this in because this is quite useful between fruits which are rich in sucrose, that's the disaccharide, and low in fructose and glucose. So some people have problems with sucrose. If you don't have sucrase, which is an enzyme that splits sucrose down into glucose and fructose, these ones which are high in sugar are apricots, bananas, dates, grapefruits, etc. Fruits high in fructose, which is the single sugar and glucose, so these get absorbed very easily, and low in sucrose. So these are the better ones, if you like, if you've got problems with not enough amylase to digest your starches and your sugars. So these are the sweet ones. You get all those lovely ones there. Okay, these are the better ones to go for. So these are fruits high in fructose and glucose, so these will get absorbed much more easily. These are much harder if you're short on sucrase or amylase. Lipase is vital not only for the digestion of fats but also the fat-soluble vitamins. Some lipase are expressed and secreted by pathogenic organisms during infection, in particular Candida. Protease is essential for the absorption of water-soluble vitamins B and C. So a lot of vitamins are carried with proteins and other substances. So fat-soluble vitamins are carried with fats. So if you don't have any fat in the diet, you're not going to absorb vitamin A, D, E and K. If, on the other hand, you don't have very much protein, you won't carry your B's and C's, which are piggybacked in with the amino acids. So the intestinal wall contains carrier proteins that transport the water-soluble vitamins into the blood. They also contain these protein transporter proteins, which we talked about, for minerals like zinc and magnesium and selenium and so on, are actually transported, they're carriers, across the cell membranes in the gut from the outside, what they call the influx, and then the efflux the other side into the blood system. These transporter proteins take in our minerals as well as the water-soluble vitamins. Proteases are involved in digesting long protein chains into short chain ones that we know. The synthesis of protein enzymes, abundant amino acid digestion is essential, and no undigested proteins must be present that may irritate the gut. So we shouldn't have undigested proteins in the gut if we've got good functioning enzymes. If we do, we're opening ourselves up to parasites, because we always eat parasitic eggs, are there every day on food and on our hands and that sort of thing. With no problem, because they stay as eggs. We don't eat parasites, we usually eat the egg or the dormant stage, and they stick to our intestinal wall and gradually they get shoved off. But if they hatch out, if there's undigested proteins, then this is just nectar for them and then they proliferate. So you're never basically, the higher protein diet a person has, the less they're probably likely to absorb it, to digest it properly, so the greater risk of developing parasites. It has been shown, however, that maybe up to 5% of dietary proteins are absorbed not as single amino acids, but maybe as short-chain peptides that have residual biological activity. Some of these could be endorphin-like peptides, influencing the immune system, nervous system, and the endocrine system. So, one of these would be glutathione. Can we absorb glutathione? Maybe, providing you haven't got high levels of GGT that we've talked about before. These small molecules get across the GI and blood-brain barrier by micropinocytosis. So they're going in there into the cell membranes and being carried across. So maybe 5% they reckon now. So let's have a brief look at these toxins, epigenetic, these toxins in the gut kit there. Things like tyramine, histamine, putrescine, cadaverine. These are substances which are byproducts of the breakdown of certain amino acids, mainly in the system. Many amino acids may undergo bacterial and fungal decarboxylation and produce these toxic amines. Tyrosine goes on to produce tyramine. Lysine produces cadaverine. Arginine produces agmantin, ornithine produces putrescine. See, most of these are not very pleasant substances, hence their name, as you can imagine. Histidine goes on to produce histamine, serine to ethanolamine. Tryptophan produces these indole, methindole and tryptamine, and phenylalanine is phenylethylalamine. Cysteine goes to ethyl mercaptins, methyl mercaptins and hydrogen sulfide, because cysteine is a sulfur amino acid, and methionine breaks down to spermidine and spermine. So these you would test from strength to see if they weaken. This is just indication that you're just not digesting proteins properly. So they are involved with a lot of psychiatric problems and health issues. Cadaverin here, foul-smelling putrefaction, the odour of urine and bacterial vaginosis. Agmantin affects different neurotransmitters. Nitric oxide synthase encourages bacteria. So there's a whole list there of different horrible breakdown products and the toxic effects that they can have on people. So if you've got good bacteria, got good digestive enzymes, you're not going to get these things. So again, 2 points of therapy: localize. And finally, let's just have a look at the, in the 4R program, we put these together: repair and regeneration. So yes, you need probiotics and prebiotics, but that's really the inoculation part of the program. Zinc you always need for repair. Whenever we got repair of tissue, you need zinc because it's the main cofactor for DNA polymerase to repair tissue. Pantothenic acid, vitamin A, and glutamine, which is particularly rich amino acid in the small intestine. As for that, biotin inhibits spores converting from the mycelium into fungal overgrowth. So biotin has a role here in repair and regeneration, and turmeric helps to close the tight junctions. Maybe cloves does as well. I haven't heard cloves, but again, this could be a good thing about turmeric and or cloves, because it helps to shut in a leaky gut person with the tight junctions. So enteric nervous system, this is just something I added at the end that my friend Richard Belly produced. If you therapy localize to CV6, that's the point that we use for the probiotics. It inhibits an intestinal associated muscle. Now, what we did here is, if you like, we used a quadricep, okay? And that is an intestinal related muscle, but it's a small intestinal related muscle. So could we have you once more? So you TL then to the beginning ending point will abolish the CV6, and then you treat the beginning points as indicated. So what we're going to do is get ready to touch on, this time you don't need to press, all right? I'll just find the spot for you. So there, okay? So if we use a small intestine related muscle, that would be the rectus femoris. Don't press, Paul. That's it. Now you see on this one she goes weak by a gentle pressure. This one I missed it, she had to press hard. Now press hard, which means she needs a probiotic, but just let it relax. So here what Richard found is you TL that point, CV6, and an intestinal muscle. So if we now cross-check on that left side to small intestine 19, which is just in front of the tragus of the ear, it should, yes, we'll take it out. Pull, it should abolish it. Okay. If it's a large intestine, then you would have used your tensor fasciae lata, your hamstrings, etc. So it's quite a nifty little way of redoing, thank you, to know that your person's got an intestinal problem. So it's a little bit like we found with things like heavy metals and toxins sometimes only show at certain times of the day, that we store them in the liver, but at liver time, you know, between 1 and 3 in the morning, they start to come out, the person starts to wake up, and they think, oh, why have I woken up? But you can't see what the toxin is unless you put the person into that using the alarm point or the colour acetate. Okay, so that's quite a useful thing that Richard showed us. And that's it. Okay.